Yeah, so morning to all. This morning we're going to produce the blade of the screwdriver. You all would have already seen how the handle was made. So we're going to work on the blade this morning. We're starting out with a stock piece of material from scratch, and we're going to cut to the length that we need, and then follow the procedure to create the blade of the screwdriver. So we're going to proceed with that. Mr. Roshan is going to take over, and he's going to start the process for you all this morning.
Alright, so first thing we want to do is go through the basic tools that we'll be using for this operation. First thing we have our drawing. Our total length of our part is 210. We will be going a little longer to cater for any excess trimming that we may need to do eventually. So here we have firstly our hacksaw. Look at our material to our desired length. We also have steel rule, take our measurements. It's in metric and English. We'll be working with metric today. Our hand tools, our hand file. We have two half-round files, one of which is a coarse, the other one is a fine. On this side of the table we have our laying out tools. Here we have what is known as the height gauge, the vernier height gauge. It's a very precise piece of measuring tool. Also we have a base square, a V-block with clamp, and our surface tape. Alright, so that being said, we'll be marking our material to our desired length. 210 out of 215 millimeters. Now the material that we're working with is stainless steel. Right? Our first operation is hacksawing, cutting the material. Now when doing so, we want to ensure that our material is very close to the vice jaws to prevent excessive vibration when cutting. Okay, so the proper position of the hacksaw, firstly the vice must be at least elbow height. We're going to hold grip the hacksaw at the front and the handle, right, to prevent any side motion. If we can hold it here, we'll have a lot of shake. We'll keep it stable, right? We're going to use the entire length of the blade when cutting. And also we cut on the forward stroke, apply force on the forward stroke, and release on the back. Next step is to just break the edges, the sharp edges that are here to prevent any injuries and so on. Okay. So now I have one file. I just want to come to the side approximately 45 degrees just to get rid of that sharp edge that was created during the hacksawing process. So that's it, getting our material desired length and also breaking the edges. Now we'll move on to the welding shop where we'll be doing the forging of the blade itself.
Right, so look at it. So what we're going to do is we're going to light the torch and we're going to heat this to cherry red and start a forge. Forging is when you hammer it and flatten it to make the blade. Right? Alright, so you set the flame. And I generally rotate the piece of material to get it easily hot. So it's at this period. is a forge. Right? The heat will dissipate, so you will have to heat it back. Right? More or less you have form like this. Let me cool it. That's the forging process. And then you'll go across to the workshop now and they will start to tell you what to do with regards to filing it and marking it up.
Okay, so after the forging process, what we're gonna do now is create a flat surface using our file. Flat and smooth surface, this will give us the size of our blade. After which we'll mark a center line where we'll take our dimensions when marking up for the angles of the blade. Okay? So we want to keep this as flat in the vise as possible. Upright. I'll be starting with my half round file. Of course, just to get rid of the heavy stuff here. Right? When using the file, hold in position, you want to hold the front of the file firmly, grab the back hand out, and then moving a forward motion like this. Okay, you want to try to use the entire length of the file across the surface of the piece which you want to file. If you notice, the file is moving just like the axle, you cut on the forward stroke and you release on the back stroke. Now, ever so often, the filing chips will get stuck into the file. You'll be using a file pad, something like a steel brush, to clean the file of those chips. So now we have flat surface, a clean flat surface. We'll just repeat the step on the other side. Right? Okay, so our next step is to mark our center line. Okay. How we are about to do that, we'll be using our height gauge, our V-block and clamp, and our surface plate. We also have our base clearance of that. Okay, so we measure our diameter using our micrometer, and our diameter was 7.97 millimeters. So our radius will be 3.98 millimeters. So now we move on to our height gauge. Our layer tools. And firstly, what I want to do is clamp our blade onto the V-block. While I'm doing this, we want to ensure that the side that I filed previously is almost 90 degrees to be surface plate. So knowing our radius, what I want to do on our vernier height gauge, if you take a look here, we have English or inches on one side, and we also have metric on the other side. The scale that slides up and down is known as the vernier scale. Right? For simplicity, we'll be using metric for our sizes. And what I want to do is firstly ensure that this pointer of the height gauge or the scriber touches the surface table. At that point, that will be our zero position, or 0 millimeters. If I were to raise and touch the top of our blade very gently. I will get the total height from our surface plate to the top of our blade. Using that value, I will then minus our radius and then our center point for our part. And if you look closely over here, you'll see that the 0 on the vernier scale lines up perfectly with 41 millimeters. So I'll now set this on 37 millimeters. Before I do that, I would like to put some marker, and I will basically color the surface to make the center line more visible. So now I'll be setting our height gauge to 37. So I'm minusing 3.98 from this point. So that's 4, 59, 53, 56. So now using our scriber tip of the height gauge, I will then scribe our center line and our workpiece. To measure using the metric rule, metric side, so we measure here. See, we're getting about 50 to the tip. So we're going to file off from here, approximately about 5 millimeters. Right? So I'll start at this point here, I'll scribe, and I'll scribe across. Right, so we blade stopping at this point. Now we're going to measure from the center line. I'll line up one of the lines on the rule on the center line, and then I will check 4 millimeters one side, 4 millimeters on the other side. Right? I line up on the center line and I check 4 millimeters mark. Then I check 4 millimeters here mark. So measuring 18 from here to the highest point here. We check 10 millimeters, 15, 16, 17, 18, which is here. Mark. Scribe this point, cross. This will be the highest point at this highest point. Remember, when you forge this, sometimes some will be wider than some, so you can measure here, and we see we're supposed to have 6 on the center line, 6 on the center line, which is about exact. Right, so we're good to go. So we can scribe this, connect these 2 points here. So now we're gonna start shape it. Firstly, I'll take this axle and cut off the excess here.
not exactly on the line, a little way away, approximately 1 millimeter away, right? And then we will file it to the line. So I'm cutting out the excess. Right. Tune it upright position. Using the file, set a file, and filing as close to the line as possible, to the layout line. Right, so that is about it for the tip. So the next step will be to file the sides. Moving this material here. This will be the scrap material. And this side here, and we coming down, creating flat tip screwdriver. Right, so you're taking out this piece here, taking out this piece here. Now when you reach close to the line, you want to be a little extra careful because you don't want to go and file down too much, right? So you start checking more and more regularly now. Make sure you're coming down parallel to the line and maintaining all your layout lines. If you look at it now, you will notice it's very close, but not 100% symmetrical. Here looking higher than here. Now you have a file and try to balance and get it to look symmetrical using your lines as guide. Right, so we're going to file on here a little more. Now that we have the outline filed already, we want to file the tip of the blade to fit on the screw here, which is the purpose of the tool, right? So we want to reduce the thickness here so that it will fit nicely in the groove without a lot of play. So you can see this one barely fitting, but it's not going all the way down. So we just need to flat file it up both sides to get it to go. Using a slightly different technique, we just call it draw filing. Using the file like this. Okay. We also improve the finish at the same time. So we file a little on one and we check. Almost starting to enter but not thin enough yet. So we file a little bit on the side now. So keep checking, and that is what you're trying to achieve. You want it to almost reach the base of the groove. At the same time, you don't want too much clearance. Right? You want it to fit snug, which is about that. That is what we're looking for. See that we accomplished, we outline the shape, thickness, all the dimensions intact. We now polish this blade and bring it to a certain finish. We start by using the file to smoothen out this area, which it's slightly rough because of the forging process, right? So we file up here a little bit, and then we use some sandpaper and polish the whole blade. So using the round side of this file to try and create a slight radius which we have on the drawing. Not removing much material, we're just trying to smooth it out from the forging process. Now I switch over to 100 grit paper, start to refine it. Refine the surface. Right, so this is something like what we want to achieve. This is the final product. To achieve this, we just need to continue polishing with the same grit, 400 grit, until we get to this surface finish here. And that will be the final step for the blade tip.